Well, since the last video, all the extra pulleys and belts I ordered have now come in, so we can now upgrade to that. And I thought while I was in here, why not measure the run out? So as you can see, the run out on the main pulley that's on the motor is pretty low. I think it's about 0.05 there. And while I was here, I thought I'd also measure the run out on the main shaft itself of the motor. That's pretty low, it's probably even less than 0.05, so pretty happy with that. So as you can see, I've now got the pulleys back to back, so that'll allow me to change speeds. Now obviously we've got the inverter here, the 3-phase motor, so we can get a wide range of speeds from that anyway. But should we need a bit extra torque, and we want to trade that for speed, we can put it on the lowest setting there and around here, and then we just slide the motor forward and backward, and we can change between those two. So I don't think I'll be doing that very often, but if I need to, I can go on this low ratio. Well, most of the time I think it will be in this high ratio. So I've got the I've got it loosened. No, just loosen the motor off a little bit. And then luckily with the same belt, I ordered some more belts, and this one here, which was A22, that's 22 inches or 590mm. I think that was the inner circumference. So just, obviously the camera's in the way, making it a bit awkward, but you can see just how quick that would be. Try not to knock the camera over again. And do it all up and then put the belt cover back on, and away we go. So that'll give me my 2 independent speeds if I want to do that. So yeah, pretty pleased with how that's turned out. So if we give it a test run now, I've got it on a reasonably high speed. I don't know if you can really hear it on the video, but that sounds really smooth. It's nice in terms of vibration. Way lower than before, way lower. I remember on my old machine I had this face would actually rattle and make a noise against here on this readout, but very nice. Now there is obviously a little, hold it still, a little bit of run out on that pulley there, and compared to the one at the rear, which is a lot better. Now let me stop it first. Now I did realise that actually that's the part that holds the taper that in here runs in those bearings. Looks like it's held in here, and it's probably quite short. In the when I look at the parts manual, and there's only a small piece that sits in those bearings. I don't know if it's a matter of just taking that out and using a puller to get it out, or whether you have to take the whole, the whole quill out, and there's some kind of fixing underneath as well. I don't know, but if it's literally just that top bit with that taper, tempting. It is tempting, but maybe for another day. Okay, that's nicely working. Let's put the cover on and let's get on with what we really need to do in this video. Okay, before we get into the video today, let me just show you what the problem is and what we need to fix. So if you've been following along on this build, you know that to move the knee up and down, I designed this system here. So we've got a handle there, turns that shaft there, there's a pair of bevel gears, and then those gears act on a ball screw, and then the ball nut is bolted to the knee, so when you turn this, it moves the whole knee up and down. Now to stop it moving down under its weight, or to stop it moving down when you drill, there's a brake system under here. So you undo this brake here, which clamps a little T-nut that's behind here in this groove, and clamps those together, and it stops this moving relative to that. So that's bolted to the main backboard, and that's part of the knee. So if we loosen that off, and then when I turn this handle, I can move it up and down to whatever position, and then when you've got the height correct, just lock it off. There we go. However, there is a problem. The problem is basically that brake is not strong enough so that when you're drilling and applying load down here, and you're pushing onto the drill bit into the material, then it's quite easy, or reasonably easy, to push this down, overdrive the gear that's holding it up, and overcome the brake, and the Z axis drops, or the knee drops. And obviously, that gets annoying after a while, and you really can't tighten it hard enough to get that grip, especially with that plastic handle. I mean, even if I turn it to the metal one, I don't think it will be any better. And in fact, what I did, so this is the old T-nut that was behind there, and I made a much longer one. You might be able to just about see it there, sorry about the light. 40mm long, so much more contact area, and that's what's in now, but it's a little bit better, but it still slips. So I think this whole concept is not going to be good enough to break the knee. Right, so I'm going to demonstrate this. So rather than drill a hole in something, I've got the jaws all the way back, and I'm just going to push the top of the chuck onto the vice body, give a reasonable amount of force, and then you'll see, because this will move up and down, or move down rather, when I apply that, I can actually overcome that with not too much effort. So here we go. It's even just pushing down a little bit. Now that's okay, because there's maybe some deflection, but there we go. Yep. Going down. I get the handle in shot over there and do it again. Zero that. Try and do it so you can still see. Yeah, basically I can wind it and move it down. So obviously that's no good, and we need to do something better. Can it be improved? Yes. So I thought about lots of different ways of doing it, different brake assemblies back here, and decided what I really need is something in here, something pretty substantial that basically goes from the centre of that to here. But obviously it's got to be adjustable so it can slide up and down and have a really heavy duty lock on it. If you think about the clamp that held the original table on, so you had a table on, the clamp was about sort of that sort of size with a big sort of a handle on it as well, and that grip round the column. That was to stop it sliding down and back driving. I need something, doesn't need to be that big, but something a bit better than this. So I contemplated things like a hydraulic bottle jack, because you'd have the base down here, you'd have the ram there, drain all the fluid out, and then just make a clamp at the top, a collar, so I can lock it off any position. I think the problem with that was, I wasn't sure the ones I looked at anyway were going to have enough stroke, because this has got to go up quite a long way and come down quite a long way. So I wasn't sure I could get that to work. About £15–20, so it would have been a reasonable way to get this problem solved. And then I thought, I got really crazy and thought, well, hang on, if they're hydraulic and I can get one to work, then I can actually have it hydraulically lifting up and down and having a separate pump. I could even have maybe an air chamber preload on it, so it's like a counterweight, so that when you're moving it up and down on the handle, it felt sort of effortless, really. Where do you stop? Someone stop me, please. So I've got some stock ready, the CNC machine's on, the lathe's on. Let's get building. Didn't sound very happy. Ooh. Okay, we're most of the way through the job now, so we're doing all the turning work on the lathe and we've split it. I don't have a slit saw, so I use an end mill, which actually is a bit better because it's opened the gap a bit wider, so I can clamp down a bit more on it. Now, I've just drilled this out 6mm. We'll take this out on the drill press to an 8.5 clearance, and it'll be a tapped 6-point or 6.8 in the bottom, and then tap to M8. So last bit to do is the counter bore here, so it'd be 15mm, and then I just want to spot face it until it's level. So there's a couple of ways we could do this. I thought I could go inside and in Fusion 360 sort of draw a circle and draw a bore, and then just create the G-code from that, if you like, because that's probably a reasonably quick way to do it. And then now years ago I used to use, well, not that long ago, I used to use Mach 3, and it had something called Brains, I think. Was it Brains, or had some kind of can't remember what it's called now. Anyway, it had little operations you could do like this. So you told it diameter, width, and it would create a little bit of G-code that would run that. Now, as far as I can tell, now in UC-CNC you've got the cam option up here, but this looks like it's for importing a DXF, so it's where you've already got some contours from a 2D file, AutoCAD or something, and then you select those contours, it looks like, and then you say what you want to do, internal, external, etc., what tool you've got, and then it will create the G-code from that. So what I want to do is just create something simple like pockets and things like that and have it parameterized, but I'm not sure that's in here. So I've just created this in Notepad. So I've got a 6mm cutter and I want a 15mm diameter sort of circle. So that's radius 7.5, but I've got 6mm cutter, so I need to go to 4.5. So make sure I don't cut it over size, and then this is a full circle I, and then that's the 4.5mm radius for the actual path I want my tool to take. Obviously it's 6mm wide, so it will actually cut 15mm diameter. Hope that makes sense. So obviously when you're doing hand coding, you've got to do the tool diameter in your head, otherwise you get the wrong size. So not tried this before directly like this, so let's give it a go. Okay, I've just drilled this out to 6.8 all the way through, which is the tapping size for the M8, and then opened just the top part, the clearance bit, to 8.5, little counter bore. So basically we're going to run the tap down in the lower half, and then there'll be clearance in the top, I'll either put a bolt in it or probably some kind of handle, because this is basically the lock mechanism. So I've just got this on low speed. I'll just get it started and then I'll probably hand finish the tap. And after a bit of clean up, we've got that. So I've put the little screw in there just to try it out. Yeah, and it grips quite nicely. Looks like it's going to work. I'll see a little bit of blue just to take off there, but basically got that part finished. So that part will fit into a tube and then it will get welded on only on one side to allow the clamp to work. And then obviously it won't be a bolt finally, it'll be some kind of handle out here with the M8 thread on the end. But just for now, yeah, you can see that that locks up quite nicely. So, one part down. Okay, so finished making the knee lock clamp now, pretty pleased with that, and I've also made some other bits. So there's a bit of tube here, also it needs cleaning up before we weld it, but that's that part there, and then there's a piece right at the top, and that's that one there. I didn't have enough stock to make this piece, so that's the actual main shaft part up here that moves up and down that will go to the base of the knee. So I've got that coming in. So while we wait for that to come in, let's head back over to the lathe, and we're making the lock handle that goes in here. Okay, it's a little bit large. I think this diameter is about 40 and the maximum actually needs 28, but I haven't got anything smaller that I can make it out of, so it'll take most of that length there. So this is the lock handle part instead of having a screw in there. So that part will go into the piece you just saw, and then there'll be a kind of bar in here with a thread in it, and then a ball on the end, so that'll be a separate piece. So we just need to basically turn that down, put some threads on it, some chamfers, and then cross drill, tap that hole, counterbore it there, so we get a nice flat seat for the piece that goes in there to sit on. And that's it really. So we'll face this off, center it, and then we'll get going. Okay, I was quite literally just getting ready to face that off, and the postman's arrived, weirdly, with this other piece. So this is the height adjust tube that moves up and down. I wasn't expecting this for a few days. I think I might have only ordered it yesterday, I don't know. Anyway, it's here. It makes much more sense because I've ordered loads of it. You know, because you're going to pay postage, you may as well order enough for some spare. And I can easily get this part out of here as well. So we'll take this out, save this bigger piece for another job, another day. And we'll put this one in. I will have to cut a piece off. Oh no, probably I might get it. Yeah, I might get it inside the jaws, even better. Right, let's swap this out and bring you back. Okay, so we've got all our features done. We've got the thread, we've got the blank piece there. That part will go into the other part of the housing, and then this is the larger part where the handle will be. So just going to part that off slightly over length, then we'll put it back, turn it around, put it back in the drawers, and just turn that down to the final length on the other side, and then the lathe work is done. Come on. There we go. Okay, and that's it. Okay, so we'll get it set up and we'll put the cross hole through here. Okay, so we've got our collet block in here, and that's holding the workpiece there. We've got a little jack just down here, and then we'll just use the edge finder just to center off there, and then pick up off this edge, and then we're right in the center of that, so we can drill and tap our hole. Okay, we'll swap that out. A 3mm spot jar, that's probably not going to reach. Alright, I'll bring the table up. Okay, we'll just gently spot that because it's on that radius. Can't get the drill in. Move the table. Yeah. Okay, we'll just pile it through this 4mm. Being a bit gentle on the pressure because I want the table to move down, because I'm making the part that will stop it from moving down. This is 6.5, and then we'll put the tapping size 6.8. Just saves a bit of wear and tear on the tapping drill. That is blunt. this one. And that one is sharp. And then finally 6.8 tapping. Now we counterbore this 3mm, so we'll put that on there. Okay, now we use our quill depth DRO and zero that. Okay, now we'll just run this quite slow and we'll go down 3mm. Ideally I want to press a bit harder and run it really slow with high force, but the table will drop. It's not going to cut very well. I'm starting. Where are we going now? 1.5, 2, 2.5. Three. Okay, this time we'll use the jog function on the machine, and then it'll just, as long as I hold that button down, it will spin it really slowly on a special setting, and that should enable us to tap the hole. So if I just press the jog button and let go and it stops, so you can just basically jog it in like that. Okay, here we go. Looks like it's trying to slip a bit. Let's go one more. Or nearly. Okay, a little bit of clean up, that should be it. Okay, let's get it out of here and see what we've got. Okay, so here's our clamp. So that should go in there. And then that shoulder there will sit against that spot face. And that's tight now. And then that will obviously clamp it up. And so all we've got to do now is just make this little bar, thread there, and there'll be a bar, which is this one. Probably make it out of that, or maybe something a little bit smaller. Otherwise I'll have to turn a lot down on that. But that will then be the handle, which will go in that way. And then I've got on order these Bakelite balls, the black round ones I've got on the end, but I don't think they'll be in time for this video to finish, so I'll just use it without just the bare handle to start with until that arrives, but I'll put the threads on it anyway. Then the other thing to note is it was not going to be easy to know, well, maybe I could have done a bit of working out, but exactly where this would be indexed around relative to when this starts to clamp up. And the reason that's important is when the knee comes down, it gets quite close like that in the lowest position, and if this handle's sticking up, obviously it's not going to work. And I wanted this rather than a kind of little fiddly plastic ratcheting type. So my plan was just see where it ends up when it's tight, because ideally what I want it to be so that the handle down here is sort of tight in that position and loose in that position. So that's the kind of the operating range, so that it's well out of the way of the knee when it comes down. And the way I was going to do that, if that will stay there, no it won't, okay. What I was going to do that was just see where this ended up when it was nipped up tight, and then I can machine a little bit off the shoulder there, so I've left plenty on there, just so this index is around to the correct position, because I guess ideally once it starts to get tight, I want it to be probably about maybe somewhere here, and then I'll just tighten it up, and then loose be over here. So that's the plan anyway. Right, so they're the basic parts. I think what we'll do off camera, we'll just make that one, it's just some turning, nothing too complicated, and a handle, turning and threads. Make those off camera, bring you back when we got everything together, and then we'll dry assemble it, and then we can start welding. Now earlier in this video you saw me just write some hand code in Notepad. That was just to do a simple circle to bore out a hole. I went a step further here, so I wrote this little Visual Basic bit of code that just runs in Excel, and it's a kind of conversational programming in that you can just type in a diameter and your depths and some sort of speed and feeds there, and then just generate the code. And then it just saves a text file to desktop, and then you can load that in very quickly, in this case in UCCNC, and there's the toolpath there you can see. It's just a quick way of just machining a hole or something very simple without having to go back to the CAM and the CAD and do it that way. So let me know if you're interested in a separate video on that, and I'll do a little bit of just a bit of talk about how it basically works, and I don't know, maybe if it gets useful or it's something that people might want to use, maybe I'll publish it somehow, maybe through GitHub or something like that. But let me know if a little conversational program that runs in Excel would be of interest, and yeah, I'll take it from there. So I just used it in this occasion just to make this, just basically bore a circle about 0.1 millimeters deep, just a bit of a reference surface so that it located the tube. So the first piece to go on will be this. This needs a little bit more of a clean up because it's going to get welded around here. It's got a little bit of paint to come off, but basically it's the right size. And that little recess there was just to give me some guidance for assembly. You see it just about fits on there, because if we look down there, there's a little clearance hole at the bottom. For this piece to go all the way through just gives me a little bit extra space because of the travel I need, so that's there. And then the clamp goes on next. So I haven't cleaned that up yet, but we'll just do a dry assembly. So that little feature there, that spigot, that will go into that tube. There we are. And that will be at the front, because this is where the handle's got to go. So the handle's got two pieces. So we've got this piece here. We've got a little flat machined on there, so that has this piece on it. I think it's the 8, isn't it? So that goes into there. Having that flat on it means it will sit nicely under there. And then I've got some 32mm, I think they are Bakelite balls. They're black, about this sort of size, sort of spheres that will go on the edge here on the M10, but they haven't arrived yet. That's fine. And then this thread will go into there. And where this ends up, it might end up in a place that makes it a bit awkward to use because the table comes down so low. So we'll work out where it ends up and then machine a little bit off this piece here on the shoulder, just so that it ends up being sort of towards the lower half in operation. So I won't tighten that up too much. So that will go on there. So this will be welded just a couple of places to the bottom. Half of this and a few little tacks will get welded to this. The rest will be free, and that will allow it to clamp up, because if we weld both pieces it won't clamp. That'll hold it in place. And then this tube goes next, and so that piece goes in there. So it's quite a tight fit. Well, it should be a running fit, because this is the bit that goes up and down. Might need a bit of oil. Or maybe when I've machined the slot, it's come in a little bit. Oh, there we go. Well, that is a good fit. Okay. Might need to lap this down a little bit, but that's the whole point of this dry assembly. And then got this piece. So that will come in from underneath, and then there's just a bit of weld relief. This feature was already in the stock. It was just a piece I had, so we'll just make that part of the weld relief in there. And that goes on there. Okay, so we've got the slots in there now, and we're ready to do the welding. This is just a bit of a splatter guard, stop it going too far rearward. Got our earth clamp on. And I've just cleaned everything up. Some degreaser. So that's looking pretty good there. Now this is a 6mm plate, and this I think is 1.5, maybe 2mm wall. So I've gone with this. I've kept the thinner gauge wire on, I think the 0.6mm wire, and I've got these settings for 3mm. We'll see how we get on. I think it may not penetrate this very well, but we'll see. If I can just bias it towards the thicker plate, that might help. But remember, this is just kind of just hold it in place. You know, the forces are downwards. I don't think that there'll be any kind of side load really. So it's just got to hold it in place really. There's no great load. So we'll put 3 little tacks all the way around. Make sure it's still dead square, and then we can run some beads around. So we'll put the screen on so you don't get flashed and blinded, and then we'll get going. Okay, next we need to put this bit on, and we're only going to weld 1/2, so let's get that lined up. I think I'm just going to balance something really big and heavy on it. Okay, so I've got welded up in a few places. I think that'll be fine. Then I've just sanded it back. So before we go ahead and get it super clean and get it all painted and so on, I thought I'd better give it a bit of a trial run and just make sure this slides through here, because I had a bit of a worry, because the plane that this surface is in and the plane on the bottom of the knee, which these are going to get bolted to, if they're not exactly the same, then it's going to load up this joint here, and this isn't going to slide through here at all. It might lock up. I will end up running oil on this, but even so, if it's running at a bit of an angle, so if these are really heavily loaded, it might not slide very well and the whole thing might not work. It might be really difficult to lift up, say. So I'm just going to give it a dry fit. We'll clamp this down using these little clamps here. I was going to use some little T-nuts, but it's really awkward to get your finger and then hold them, so I've made these extra long pieces that go in there. So we'll give it a try. We'll bolt it into there, and then see how easy it is to move up and down. If necessary, we'll put some oil on there, and then we'll put a clamp in there and clamp it up and just see if that nips it up, and then undo it and see if it springs back enough so that we can move it up and down. And if it all works okay, then we can make it look nice, and that will hopefully be that. So let's get this bolted in. A little bit tighter, and I can do this one. Oh. Okay, so we've got the knee set pretty high, it's about as high as it will go. So what we'll do, we'll release the brake, hold onto the handle, and just see how easy it is to go down, and then we'll try going back up again. Okay, so my right hand's on the height adjust handle up here that moves the knee up and down, so I'll hold that to make sure it doesn't fall, and then take the brake off, or the current brake I should say. And if I let go of the handle, okay, it doesn't fall, but if I wind down, yeah, it's sliding through there. Yeah, okay, I think with a bit of oil on there, we'll be careful because if it slams down. I think with a bit of oil on there that'll be okay. What about going up again? Oh, yeah, there's a bit of effort, but it is going. Let's lock that off. So the question is, because I could oil that now and make sure it's okay, but then for painting it, I've got to obviously get any oil residue off here to get the paint to adhere. So I'm tempted to gamble. It feels like with a bit of oil it will go. So I'll strip this down, paint it, we'll put it back on here, and then we'll get some oil on there, and fingers crossed that does it. So I'll bring you back in a minute when that's done. Okay, so I've given it a little bit of spray paint. The trouble is it was the last little bit in the can, so it hasn't really covered, so you can see it's quite patchy. So I've just used some emery just to knock it back, and that will just serve as the first coat. At least it'll stop any flash rusting on there, and it'll keep it going while I just dial it in and just make sure I'm super happy. We've still got the little Bakelite knob to arrive. That's on its way. I guess I'll probably get the video out before that arrives, but that's okay. Yeah, so we just want to make sure it's functioning, so I'll just put some oil on there and we'll just whiz it up and down and see what we got. Okay, I'll put my hand on the handle and then undo this. See if it falls under its own weight. No, it's probably because a bit of friction in there. And can we wind it down? Well, that's quite smooth. And up. Yeah, there's a little pressure on there. It's probably fighting that a little bit, but maybe that'll bed in. Try keep putting more oil on it and run that in, but how far down can we go? About there, I think. Yeah, that's locked out on the ball nut, so that's fully down. Alright, let's wind it up. Put it about in the middle, lock it off. Okay, it's a little bit crude, but what I'm going to try is just pushing down the quill, just with a modest amount of drilling pressure. And just when it's touching there, we'll zero Z. And then I'll just pull down and we'll just see how much it deflects. So that's actually how much the table is going down, or something's kind of bending. That's pushing pretty hard. Now, does it stay there? Does it come back? I've lost 0.03. Okay, let's try it again. pretty hard. 0.03. It's probably just the last bit of flex in the whole system when you're pushing down, but at least it doesn't push it down and keep incrementing it down. It does actually come back, so it's obviously just bending and coming back. Yeah, I think for what it's intended for, that is pretty good. Alright, good. Make sure we're definitely locked off. That's the T-nut. Just had a thought, am I going to be able to get this out? I'll find out in a minute. I'll have to lower the table or something, or take this off. Yeah. Oh. Well, I think it's fair to say that put up a fight. And getting in there with tools was a right pain, but I think it was easier than disturbing the head at the top. Right, let's tidy up and onwards. Okay, that about wraps this video up. I'm really pleased with that knee stop. I think that's much more industrial, much more solid, and should last quite a long time on here. And you know, it works really well. It stops it sinking down, so pleased with that. It's been a long old build. I think this has been over 2 years now, but you know, sometimes projects go like that. So I've got one more video to do, the last video, which I think I've got one more little job to do on this, and then we'll put it through its paces. We'll definitely finish it in the next video, so if you want to see that, you don't want to miss it, make sure you subscribe. Any comments welcome as well, as always. Do enjoy reading your comments, and see you next time.